The multimodal biometric repository is the central part of our solution. This repository contains the hashed counterparts of the biometric templates of different modalities of the individuals, and various third-party apps can use this repository, or the front-end apps can build on top of this repository to offer the biometric authentications. The enrollment and storage of the hashed biometric templates is done at repository, and the matching part, the feature extraction while matching, and the matching has to be done by the third party programs. There will be a dedicated program for feature extraction that can be installed on the third party apps, and those apps can easily interact with the biometric repository to implement the multimodal biometric authentication. The helper data and keys in our specific encryption style are stored or updated in the repository, while enrollment on any of the front end or third party apps occurs. And these third parties can use the public helper data for authentication, and with the fuzzy logic and repetitive sketches, they can rediscover the key, and the key can be matched in the repository to reveal identity of the person. Once the individual is enrolled, or it's any modality template, biometric templates is added to the repository, then no subsequent enrollment is needed on any of the third party apps, and hence in general or in principle it is possible to have an app where no user registration is needed, and just by the biometric scan the identity is revealed. So the elimination of the or minimization of the enrollment step is a big advantage in current scenario. If any of the app uh, enrolls or scans the additional modalities, say the fingerprint or iris scan, heartbeat, etc., then that modality is updated in the repository for the corresponding individual, and those multiple modalities are get available for subsequent authentications. So the authentication part or the matching part can be done independent of the uh, repository or independent of the enrollments, and it offers the autonomous operations. The third parties can implement their re-authentication cycles in according to their policies, and the re-authentications can be done for multiple modalities. For instance, the if the access is granted on fingerprint, then subsequently meanwhile within the session the re-authentication can be requested based on the face recognition or iris or any other modality. And as this re-authentication cycle or the specification can be designed by the third parties independently and autonomously with complete liberty, and no AI or generative technology or even the quantum computers are capable to produce, synthesize multiple modalities of single individual, the multiple templates in sequence. It is almost impossible, and hence this architecture offers the complete security from the generative attacks or any of attacks. The biometric repository has two parts. One is the public part and one is the private part. We use the secure sketches and fuzzy extractors for encryption of the biometric templates, and they lead to the helper data and key, the pair, the helper data and key pair for each template. The helper data is publicly available, and it can be freely used, and the keys are used to recover the matching of the person. So the helper data is used by front-end apps in public domain, and with the matching algorithm after the feature extraction, the keys are generated, and these keys can be matched with the repository, so that the matching of the keys and the subsequent identification happens through the API calls, and the helper data can be made available in public. So the original templates can't be recovered from helper data, as it is very strong authent encryption technology for biometrics. And the third parties can freely request the identification or keys for different modalities according to their re-authentication sequence. And uh, as AI can't you generate the multiple modalities for single person in sequence, it is highly secure.